In the first part of this course, we learn in very broad terms the concept of voltage and current. In the following lessons, we will learn the same concepts, but in more detail. We will start with the concepts of current and charge. The following figure shows a very simple circuit which consists of a voltage source connected to a conductor. This can be a piece of wire of an arbitrary length. We know that when there is a voltage difference between the terminals of a conductor, this difference in potential induces a current. By convention, the current flows from the terminal with the higher voltage to the lower voltage. This is called polarization. In this case, if the current flows from the left to the right, the terminal in the left must be the positive and the one in the right must be the negative terminal. Following a convention to establish the directions of the currents and the voltage is very important when analyzing circuits. If we don't stick to a conversion, we can end up with incorrect results. Let me explain you the convention used in this course, which is the most commonly used in electrical engineering books. Most of the diagrams shown in this course are made with Wolfram System Modeler. Here you can see a diagram containing voltage sources and resistors. You can see that each resistor has two terminals. One is colored in blue and the other in white. The blue terminal is considered the positive pin, while the white is the negative. This means that we expect the current of the resistor 1 to flow from the left to the right. You can see that there is a voltage source connected to the resistor. We are connecting the positive to the positive of the resistor and the negative to the negative. However, on the circuit at the right, we have connected the resistor in the opposite direction. Does this mean that we are connecting it wrong? Well, not really. Let's see the simulation results in order to understand what's happening. Here we have the plots showing the current and the voltages obtained when simulating this circuit. Let's focus on the blue plots, which show the results for the circuit in the left. We can see that the voltage of the resistor is 1 volt, while the current, it is 1 milliampere. But for the other circuit, we can see the results in orange. In this case, the voltage of the resistor is minus 1 volt. This means that the negative pin of the resistor has a voltage that is higher than the voltage of the positive pin. Similarly, the current is negative, which means that the current is entering through the negative pin and exiting through the positive. So both results are valid. You just need to remember that when you simulate or calculate a circuit, if you get a negative voltage or current, it just means that the polarization you assume is the opposite. I would say that this convention, which is the most commonly used, is very intuitive. However, it is not how electricity really behaves. We are assuming that there is a flow of positive energy going out of the positive terminal of the battery, and this positive energy flows in the direction of the current. The terminal it touches first is polarized with a positive sign. But in reality, we have a flow of negative energy in the form of electrons. The electrons flow in the opposite direction, and being negatively charged particles, the terminal they touch first is the negative. In practice, when designing circuits, we don't really need to bother with the direction of the electrons. As long as we stick to the convention, our calculations will be correct. Each electron that flows through a conductor has electric charge. The current, therefore, is a measurement of how much energy is passing through a section of the conductor. The official definition tells us that the current is the derivative of the charge. If you remember derivatives, they represent the change of a variable over time. In this case, it is how much charge, in coulombs, flows over a span of a second. As a curiosity, a single electron has a charge of minus 1.602 to the power of minus 19 coulombs. That's a very tiny charge. If we have a current of 1 ampere flowing through a conductor, That means that we have minus 6.24 to the power of 18 electrons flowing every second, which is a very, very large number. To finalize this lesson, here's a quick summary. The current is the flow of electric charge through a conductor. The unit of current is called ampere, and it is given in coulombs per second. In reality, the electrons flow in the opposite direction of the current. But if we stick to the convention, we will avoid problems when performing calculations or simulations.